And before I start plotting position and velocity, I think what I want to do here is that I really want to look at the curve first. Okay, so I'm going to come in here and I just have the graph and I haven't started plotting the motion, but I want to interpret what's going on here. So if I look at this thing here, my job here is that before I go to plot, so before plotting position and acceleration versus time, let's conceptualize the motion first. Well, I think it's pretty clear that when I start to look at the first piece at least, right? Let's look at this first piece. If I look at from 0 to 6 seconds, right? So I'm talking about an interval right here. The fact that I have a positive slope, right? The fact that the slope is positive, that must mean that I have acceleration that's positive along this line. So I know that in this region, I must be speeding up. Speeding up where? To the right. So in other words, from 0 to 6 seconds, I'm speeding up. And if I look at the slope of this guy, right, the slope of the velocity curve tells me that I got to get this guy right here. And if I look at the slope, note that the slope of this guy, it's the rise, which is 6 minus 0, over the run, which will be from 0 to 6. So therefore, my acceleration is 1 meter per second every 1 second. So that's my acceleration for the first interval right there. So I know I'm speeding up by that amount. Now, when you look at the second piece here, the thing that really sticks out to me is note that at 9 seconds, I know that the speed is 0. So if the speed is 0, that means that I'm doing what? There's a change in direction. So if there's a change in direction, remember what we said before, anything that's in the positive like this is going to the right. Anything that's negative down here, that means you must be moving to the left. So we're going to the right and we're speeding up going to the right, right? Maybe I should have shaded this area right here. So we know we're going to the right up for 9 seconds. After 9 seconds, we stop temporarily and then we change directions and we go left. But now let's look at this. So if I look at this a little bit more careful here, what we're seeing here is that note that this is a constant deceleration here, right? There's a slowing down. So what I need here is that I see that for an interval between 6 and 9 seconds, what I'm seeing here is that if I look at the slope of this guy, what does it look like? Well, look at the peak. I'm going to pick this point and I'm going to pick the point at 9. So if you look at this, I start off, my speed at slope at 0.9 is 0. My speed at 6 seconds is 6. But then I look at my time interval. My time interval says I go from 9 to 6. So this is 9 minus 6. So note that this is minus 6 divided by minus 3. Plus 3, excuse me. I get minus 2 meters per second every 1 second. So what you're seeing here is that the acceleration for this second interval is a higher deceleration than the acceleration. So if I look at the magnitude of this guy, I'm really slowing down much faster. And that makes sense because you look at the slope and you go like, yeah, you could see that dude is slowing down. So in this case, what you're seeing here is that now let's look at this thing here. look at this guy here. The velocity is positive, but the acceleration is negative. In the second half, my velocity is negative and my acceleration is negative. So you're seeing that after 9 seconds, I am speeding up. So picture-wise, just from this graph, what am I seeing here? Okay, so let's draw a motion diagram. So if I'm drawing a motion diagram, let's look at the first one here. So I'm seeing here, I start from rest. Okay, I'm starting from rest. Here's my rest. And then what do? I speed up. I'm going to speed up to, let's say, this point right here. Now note, even though this is 6 seconds, note that I'm only drawing 3. So this is 6 seconds, this is 0 seconds. Should I draw 6? Yes. But I'm not going to, because we're trying to get a pictorial image of what's going on. So when you're looking at this guy here, note that the acceleration in this case is positive. I'm speeding up. When I get to 6 seconds, we see that this value here is 6 meters per second. And then what happens? Well, we know that this acceleration is a positive 1. Oops, wrong color. This is a positive 1 meter per second every 1 second. So now what happens after 6 seconds? I start to slow down. How am I slowing down? Well, this acceleration now is my green acceleration, which I labeled this as 2, and I should have labeled that as 1. So this green one says that I am changing speed by 2 meters a second every 1 second. So that means I'm going to slow down, and then what am I going to do? At some point, I'm going to stop. And this is the point where that speed is 0 here. Okay? And so what happens here, when I come to 0, this is occurring when? At 9 seconds. So now, what do? I continue to do what? I continue to accelerate. And this time, what am I doing? I'm still at 0, but now I'm going to speed up in the opposite direction. So if I speed up in the opposite direction, what am I seeing? Well, my speed's going to go, but this time I speed up faster. Why do I speed up faster? Because my acceleration now is minus 2 meters per second every 1 second. And so I get up to a faster speed in a shorter amount of time. So then I see my velocities are speeding up faster in a shorter amount of time here. So that's what it looks like graphically. Let's go in and see how we could plot these guys. So let's do that. So now we want to plot X and A versus T. So here I go. So I'm going to go like this. Let me see. I think I'm going to do it. I know that there's no negative position. So I have A, V, X. Of course, everything is with respect to T. So let's go plot my velocity curve. So the first thing that I'm seeing here, right, is that I see something, let's say it goes like this to this point, and then it's going to have a steep descent. Okay. So what I'm really seeing here is that I'm breaking this up into 3 locations here, but guess what? It's not 3 intervals, it's 2 intervals. But I'm only doing this just to sort of make it a little bit clear. So here I go. So what you're seeing here is that the first portion of this curve is doing what? It's speeding up. So if I'm speeding up, then my slopes must be doing what? Increasing. Okay, here's my slopes. Why is it increasing? Because I have what? I have a positive acceleration. And then what happens here? I now start to slow down and I come to a stop quickly. So I try to come to a stop quickly. So that means that once I get here, I better have what? I better have a slope of 0 here. Because why? That speed is 0. So when I'm looking at the acceleration though, what you're seeing with the acceleration is that the acceleration has really changed here. It instantaneously goes down to a larger value. And so now I have an acceleration A2 that's minus 2 meters per second every 1 second. So then what happens? I start to speed up. So as I start to speed up, what I'm seeing here is my acceleration then tells me that my slope in the negative direction is getting steeper here. And so that's what my curve looks like, right? That's my change in direction. And that's what my curve would look like right there.